number 1 on your sheet. In the study of heart surgery, one issue was the effective drugs called beta blockers on pulse rate of patients during surgery. The available subjects were divided at random into 2 groups of 30 patients each. One group received a beta blocker, the other group received a placebo. The pulse rate of each patient at a critical point during the operation was recorded. Treatment group had a mean pulse rate of 65.2, standard deviation of 7.8. For the control group, the mean pulse rate was 70.3, and standard deviation was 8.3. Construct and interpret a 99% confidence interval for the difference in mean pulse rates. So, skipping ahead without doing all the defining, what would make most sense for our subscript letters here? So, which one does it mention first? Which one did give me the mean of first? So, I would have had to define all this and whatnot, but I'm just doing this for the calculator portion. So, if I'd already defined subscripts and all that, we're going to use B as beta blocker and P as placebo, just so it's not as obvious as capital B. So our X bar capital B is 65.2. Our S of B is 7.8. Our N of B is what? Tell us initially. 30. And then our X bar of P is 70.3. Our S of B (8.3), and our that's a P. Our N of P is what? So writing all the things that I have to have in do, what am I missing here? That have to be there. Confidence level. So I've got a 99% confidence level. Now, this is where it gets a little funny, where I'm kind of cheating. Let's go ahead and write out the equation generic first. I know that my equation is going to be, so let's just say I'm going to do it the way I wrote it up there. So I'm going to do X bar B minus X bar P. I've got both of that. So when I write this and I'm checking to make sure it's okay that I don't plug in all the numbers, as you're writing, be like, yeah, okay, I have that one. Yeah, okay, I have that. Plus minus what? I don't have that right now. We're going to come to that. And then square root of what? So tell me exactly how to write in the square root part.
S squared B.
So make sure that you're doing your squared here and not on bottom. And then S squared P over NP. I've got all that up here, so it's good. So the only thing I might have an issue with right now is T. So we're going to kind of cheat ahead and go to the calculator and see what happens. So in my calculator, what's the first button I push? Stat, and then I go over to tests. Well, as always, the first 6 options are tests. Do I want to be doing a test? No, I want to be doing an interval, so I want to go to where I'm looking at the ones that are intervals. So which one of these intervals is it? 2 sample T. So just going through these, 7 and 8, it doesn't have a 2 in front, which infers that it is 1. It doesn't say proportion, which infers that it is mean. So then 9 and 0 do not say the word proportion, so it infers that it's mean. It is 2, so we're doing a 2 sample T interval, so we're doing 0. And as always, we can use data or stats. Well, we don't have the data in lists, so we're going to use stats. So my first X bar is what? The way I wrote it. 65.2. My S1 or S of X1 is 7.8. And my first N, 30. My next X bar, 70.3. My next S, 8.3 with a sample size of. So right now it should look like those, my numbers plugged in. Now I get options underneath that. My next option is sea level. Well, what is that? It's my confidence level. What I want my confidence level to be? 99. And then it has this option that says pooled. Now we've dealt with pooled, which was yesterday. Did we have the option to do pooled yesterday? No. If we did a test with proportion, it pulled it for us. Having the option for pooled is something we don't have to deal with this class. So, no. And I'll talk about it a little bit tomorrow, but no. So, calculate. And it is going to give you all of this. What's one thing that you see that is a little weird? Degrees of freedom. We have never seen a degrees of freedom that is what? A decimal. It uses this really, really, really long equation to figure out what the degrees of freedom is. But what do we not see on our results? An actual T value. So this is kind of weird, but I'm actually not going to write one. Because if I wrote one down, it wouldn't match what my answer gives me. And that is a bigger issue. So I use the calculator. And if I use the calculator, don't write down degrees of freedom because that's also going to contradict it. Unless you wanted to write down that degrees of freedom that's there. So we are actually not going to have a T written anywhere, and it is okay because using this procedure with these numbers gives you this T value, and that's why it's okay. So then our answer is going to be written as, what's our lower bound as far as we can see it on our calculator? And I don't know why the calculator chooses to go to some decimals for one and some for another. I guess it's because of number of characters, which I don't love, but we deal with what we can. Less than or equal to, and then we're going to have mu what, the way we wrote this problem. Mu b minus mu p up to 0.43904. And now, because I'm not writing the conclude, what are my units? Does it really? It doesn't give it to us very well, so we could just write what? Usually there's units for that, but I'm not going to expect you to know anything outside of content to know what the pulse rate should be in units. So let's just talk through this one really quick. So this one for state, what would be context that we fill in for both of these? The mean what? Pulse rate. We could probably get a little bit more specific and say pulse rate of patients during surgery. And then so population 1, we would be calling what? What would our first population be? Patients who were receiving the beta blocker. Our population 2 would be patients that were receiving the placebo. So we want to estimate the true difference in means. Here we would say mu of capital B minus mu of P with 99% confidence. This would be a 2-sample what? T interval for difference in means. What about this one for random? So what does that mean? This is random assignment. Why? What is being done in this problem? It's an experiment, and they are assigned to a treatment group. So we would say here that these patients were randomly assigned to either the beta blocker or placebo group. Normal, which process would we be using here? Hang on. Hello? Okay, thank you. Daniel, have early dismissal. So which one of the normal would we use here? Central limit theorem. We would write both of them are greater than or equal to 30, so we can use normal approximation. Independent 10% condition. We would say this one gets wording can get a little funny. We would say there are at least 300 what? So what could I write for here with there are at least 300 what? Surgery patients, I might say, who could have been assigned to either the placebo group or could have been assigned a beta blocker. So that one kind of wording-wise, just with this problem, could get a little bit funny. But nothing really changes there. We've already done all of do. Our conclude would just be we are 99% confident that the true difference in means mu capital B minus mu P falls between whatever we just said, the negative 10.64 pulse rate and 0.43904 pulse rate. Questions?